This would give us a much more complete picture of the world as far as we're concerned because of its solid parts. From now on, a great picture has been seen everywhere thanks to the James Webb Telescope. Discover the James Webb Telescope with us and learn how it could change everything. Find out how it all began when the idea for the telescope was first put forward in 1996. The experts and engineers from 3 different groups, both public and private, got together to see if NASA could really build the telescope. All 3 groups came together with the same goal in mind: to put together the telescope. NASA decided to pay for more tests in 1997 in order to meet the more specific and expensive needs. As of 2002, the building of the Telescope Association had chosen groups to build the telescope's most important tools and an advising committee of experts to help with the building cycle. The telescope was originally named the James Webb Space Telescope that same year to honor the former head of NASA who did a lot to help build the Apollo program. When engineers and scientists started putting together the Webb telescope in 2004, they thought they would have to come up with new technologies and methods to meet the mission's important scientific needs. Explorers in space could fix and improve Hubble while working from Earth, but Webb would have to do its job from too far away for Earth to accommodate. Even with these problems, the team finished all 18 pieces of the reflected mirror and put them through a strict set of tests to make sure they were up to code. At last, it was possible to picture the telescope going into space and taking care of its job. From 2012 to 2013, the James Webb Space Telescope was built and put to use. Big parts of the telescope were being built all over the world in different places. In 2013, work began on Webb's sunshield layers. These layers protect the telescope from too much force and make it work perfectly in space. Over the next few years, Webb's unique scientific tools were put through very tough tests that included shaking and high temperatures. Its 18 different mirrors were carefully set on its backplane the whole time. The NASA Johnson Space Center in Houston, Texas, got these parts and tested them. The telescope and its tools were put through one last round of environmental tests in a huge thermal vacuum room in 2017 to make sure they would work properly when they were sent into space. Webb was finally sent into space around Earth at 7:20 a.m. Eastern Standard Time on December 25, 2021. How does the camera really work? People often make space travel sound easier than it really is, so when you first hear about it, it might just seem like another camera. It wasn't like that. It was very unexpected, which is why it took so long to go from idea to start day. A big telescope called the James Webb Telescope was built to see things in space that other telescopes can't see because they are too cool or weak. These are things that are just starting to form, like planets, galaxies, and stars. The telescope is made to pick up infrared light, which is what these faraway heavenly bodies use to send most of their heat. We can learn more about these things because of this. We see it as cloudy because infrared light can't get through the gas and dust. Webb, on the other hand, can see ultraviolet radiation as well as visible light and infrared radiation. This lets it take pictures of things that are hidden by gas and dust, which gives us a better look at what's going on in the universe very far away. Using infrared light, you can also focus on the features of things on Earth, such as their chemical makeup and temperature. Infrared light is important in many areas of science and progress. It can help us figure out how stars, planets, and other celestial bodies are made and how they change over time. It can also be used to look for signs that chemicals are polluting the air. The telescope has many image and spectroscopy tools, as well as state-of-the-art thermal control systems that let it work in harsh environments like space. This is very important because this camera is meant to go into space by itself and handle anything there without any help. The telescope was sent into space and then separated from its launch vehicle. It then unfolded and began a long, complicated trek to get to its goal. This cycle had a few important points, like passing the moon and breaking up into different pieces. When it was all set up, the telescope was one of the most useful tools of its kind. Let's look into the steps that this very important camera took to get into space. That was the first thing that had to be done before we could talk about why it was so important. The solar array was put together after the rocket took off. On the third day of the trip, 2 very special beds were set up while the shuttle was still in the case. These bags were used to store Webb's important sun shields. The camera stays cool with these shields, which lets it work right in space. It was very important that these shields were placed correctly so that the camera could work well on its trip. The tower that held the instrument package was moved to its final spot and put together on the fourth day. This process had a lot of hard steps, but everything went quickly because of how the telescope was put together. The sun's stress then increased the speed overlap, which creates a force that keeps the camera steady. The sunshield layer cover was then put in place, revealing sun shields the size of tennis courts. The sunshield and midperplex were sent after everything was set up. The sunshield's 5 pieces were then moved apart. It's not over yet, though. Before the James Webb Telescope could be sent into space, it had to go through a number of important steps. On day 10, the second mirror and a frame to hold the smaller mirror in place were set up. After that, on day 13, the main mirror wings were stretched out, giving the telescope its final shape. Once these things were done, the telescope was ready to start its job of finding faraway stars and planets. The James Webb Telescope is interesting because it wasn't just designed to do one thing. It's supposed to do a lot of different things. Going back in time will help us learn more about this. Telescopes like the James Webb Space Telescope can be used by cosmologists like Daniel Einstein, who works at the Harvard-Smithsonian Center for Astrophysics, to see galaxies when they were just starting to form. Globes far away seem older than they really are because light moves so quickly. The telescope can study galaxies' early past to find out how they formed and how they have changed over time. For example, Einstein was able to get a full picture of how galaxies form and change over time by looking at different galaxies at different stages of growth. Webb is great for studying galaxies far away because it can see infrared light. Since the universe is growing, the light from these galaxies gets longer over time. This changes the wavelength of the light from visible or ultraviolet to infrared. Because Webb is big and cold, it can see much farther into space than other telescopes and is great at picking out infrared signals. In this way, it can watch galaxies change over time and take pictures of those changes. Webb lets us study how galaxies form and change over time, which helps us learn more about the universe. Scientists can look into how stars are made. These thick clouds of gas and dust are where stars are born. They are called stellar nurseries. Scientists can't use normal optics to study these places because the clouds are so thick that visible light can't get through them. Infrared light, on the other hand, can get through the dusty clouds better than visible light. This lets scientists see deeper into the core of these areas where stars are being formed than with other tools. Researchers will be able to learn a lot more about these places than they could before because the Webb telescope can see infrared light. Maria, a space expert in infrared light from the University of Arizona, is in charge of one of Webb's cameras. She says this is because red light is better at getting through the dust in the air than blue light because it has a longer range. Also, infrared light is better at getting through dusty parts of space than visible light. This makes the sun look redder at night than it does during the day. Hubble has only been able to look at how stars move on the surface because Webb can see infrared light better. Webb's wider range of infrared bands will help scientists see deeper into the dust and learn more about how stars are born and grow. Black holes are some of the most mysterious things in the world because they can trap light, which makes them hard to study. We can see, though, how black holes change the galaxies and stars around them. Using telescopes like X-ray telescopes, researchers have looked into many aspects of black holes. For example, they have looked into how the great destruction of nearby stars heats up and energizes the area around black holes. NASA's Webb telescope will be able to see infrared light, which will help scientists learn more about black holes. Scientists can look into the cooler gases and stars that move around black holes to learn more about these strange objects and the complicated physics going on nearby. Even though black holes can't be seen directly, scientists are still studying them. They will remain an important area of research for a long time to come. When you look at stars in thick, dusty parts of space, it can be hard to see exoplanets. This is why we need Webb telescopes. These problems are too big for optical telescopes like the Hubble Space Telescope to handle. Cool thing about Webb is that it can pick up light from stars even when there are clouds of dust in the way. This means that scientists will be able to use the telescope to see parts of space that aren't visible right now. The James Webb Space Telescope can study light from stars that is blocked by dust and gas. Scientists will be able to learn more about the stars and how they work. They will be able to look around the building, learn about the parts that make up stars, how they're made, and how they change over time. Researchers will be able to look at stars in new ways with the help of the new data. This is possible because Webb can pick up infrared light. Planets that go around stars other than our own are called exoplanets. This will help us figure out if there is life somewhere else in the world. Exoplanets are hard to find because they are small and don't give off much light compared to the stars they circle. Most of the time, the brightness of their host stars makes it hard to tell them apart with regular binoculars. Scientists can find exoplanets and learn about their atmospheres in a number of different ways. The Webb Telescope uses some of these methods. Scientists can figure out a planet's size, mass, and temperature by watching how its light fades when it passes in front of its home star. Spectroscopy can be used to figure out what is in the atmosphere of a world. A lot of big exoplanets have already been found, but the camera is also great at finding small ones. As time goes on, cosmologists will be able to study many worlds, even ones that are smaller and closer to Earth. Astronomers will be able to use the James Webb Space Telescope's high-tech tools to study these smaller worlds and the space around them. This will help us figure out if these planets are habitable for living things. It is important to study the atmospheres of exoplanets. One of the best ways to learn about a world is to watch the light from a star pass through its atmosphere. When light goes through an exoplanet's atmosphere, it leaves behind patterns that scientists can use to figure out what chemicals are in the atmosphere. This is especially helpful for finding water, which is necessary for life. With Webb's high-sensitivity cameras, it will be easier to spot these trends, which will help scientists learn more about the atmospheres of other planets. With the telescope, they will be able to learn about the past and makeup of the atmospheres of other planets. When an exoplanet moves in front of its mother star, Webb can see how the light changes. You can use this method to find out how big the planet is and if it has any moons or rings. Scientists can use all of this data to learn more about exoplanets and decide if they are habitable. To learn more about how planets form and change over time, scientists need to figure out how exoplanets work. Webb's observations of other worlds can help us figure out how our own solar system came to be and how it works. They can also show how planetary systems are put together and how they change over time. Researchers will be able to study exoplanets better and find ones where living things could survive. Webb's cutting-edge technology will make it easier to learn about smaller planets and their environments. This will make it easier to find worlds where life might be possible. Some of these are near-infrared spectrometers that measure how rocky planets are made, and mid-infrared cameras and spectrographs that measure how hot or cold planets are. Scientists can learn more about the surfaces and atmospheres of exoplanets with these tools, which will help them figure out how they formed and how they have changed over time.